So we're going to go back to the slope formula. Remember that we've talked about the slope formula being a measure of the steepness of a line or rate of change. We also learned the formula being rise over run, the change of y over the change in x. Now we're going to go a little bit more detailed to get a little bit more detailed formula. So let's say I have a point here and a point here. It doesn't really matter where they are. We're going to call them general x comma 1, x1 comma y1, meaning the first x point and the first y point. And then we'll call this one x2, y2. So this on the x-axis we have a point at x1 and we have another one over here at x2. On the y-axis we have a value at y1 and another one at y2. Now previously we talked about slope being the measure of the steepness. We've talked about it being the rise, how far does the points rise versus how far do the points run. Okay, so my red distance is going to be my rise. Well, how am I going to figure out what that red distance is? If you move that red line over to the y-axis over here, how am I going to get that distance? Well, in a lot of students it's hard for them to see that the y2 and the y1, how to get the distance between it. But if I put like values next to it, for example, what if this was 7 and this one was 3? How do you get the distance between 7 and 3? Well, that's easy. We just take 7 minus 3. Well, that works the same thing with variables. If my distance up here is y2 and my distance down here is y1, the distance between them is y2 minus y1. Now I'm going to erase the 7 and the 3 because it's not really part of my problem. I was just trying to get you to think about how to find those values. The green distance is the same green distance on the x-axis here. How do we find the distance between these two x values? Well, the same thing we did on the y. If I take the x2 minus the x1, that gets me the distance between the two. For example, if this was 3 and this was, I don't know, 6, to get the distance between them, we would take 6 minus 3. So same thing with variables, x2 minus x1 gets you the distance between them. So we talked about slope being m. We talked about it being the change of y over the change in x. So now we have values. If I have an x1, y1 and an x2, y2, if I have two ordered pairs, to get the change in y, all I'm going to do is take this y values and subtract them. y2 minus y1. And then to get the change in x, I just take the x values and subtract them. So this is our slope formula given 2 points. Using the slope formula, I want you to find the slope of the lines that pass through these following points. So when I'm using the slope formula, the easiest thing to do is to label all of your values x1, y1, x2, y2. x1 means hi, I'm the first x. y1 means hi, I'm the first y. So it's just the 1 and the 2 aren't really like squares or anything. They're just saying, hi, I'm the first one, I'm the second one. So when I plug in my formula, now my formula is m equals y2 minus y1. Now I went ahead and put the minuses in there because there's minuses in the formula. And now I'm going to go find the correct values. y2 is the first value, and that's 4, because I've labeled it 4. The green minus is because there's a minus in the formula. y1, which is 0. And the denominator, x2, that's 0, minus x1, which is 7. Now that I have the values incorrectly, I can subtract and simplify. 4 minus 0 is 4. 0 minus 7 is negative 7, so my slope is negative 4/7. Remember we said with negatives, the negative can go on the top, the bottom, or out in front. Either way, it doesn't really matter. Let's do this again. x1, y1, x2, y2. For my slope, I have y2, which is 9. Then I have a minus because there's a minus in the formula. y1, which happens to be negative 5. So the green minus is from the formula, the red minus is from the negative on the 5. In the denominator, I have x2, which is 1, minus from the minus in the formula, that's the green minus, x1, which happens to be negative 2. Make sure you go nice and slow and that you're pulling in the values correctly. Now I can subtract minus and negative, that really is add a line, change the sign, so that's 14. Add a line, change the sign in the bottom as well, and that gets me 3. So my slope is 14/3. Remember, we like fractions for slopes. Let's label again x1, y1, x2, y2. So my slope formula is y2 minus y1. The y2 is negative 5 minus, because there's a minus in the formula, y1, which happens to be negative 5. In the denominator, x2, which happens to be negative 1, minus, because there's a minus in the formula, x1, which is 3. Now I can add a line, change the sign in the numerator, and get 0. Negative 5 plus 5 is 0. Negative 1 minus 3 is negative 4. But 0 divided by any number is 0. So this slope is 0, which is going to produce a horizontal line, because we know all 0 slopes produce horizontal lines. One more, let's have x1, y1, x2, y2. So my slope is m equals y2. My y2 is 5 minus, because there's a minus in the formula, y1, which is negative 2. In the denominator, x2, which is 7, minus, because there's a minus in the formula, and x1, which is 7. And now I'm going to simplify. So 5 minus a negative 2, add a line, change the sign, that's 7 in the numerator. 7 minus 7 in the denominator is 0. And 7 divided by 0 is undefined. So my m is undefined.